All right, real quickly, I'm going to breeze through C++. Actually, no, we're not going to talk about this at all today because that is next class. But let's go over your homeworks. We already went through lab 6. So let's go over to lab 5. All right. It is vital you understand pointers, so we're going to do one more pointer exercise. I did this one with a PDF. So just write a text file with your answers. Let's see, we have different memory spaces. Note, when a question asks for the value of a variable, if I'm asking what the value is, if it is known, write the exact number. If it's a memory address, write what the memory address is pointing to. Example, the variable x holds the memory address of variable y. So don't give me a number, give me that what it's pointing to. Because I know you're just going to copy and paste this in and run it and see what happens. That's not necessarily going to give you the correct answer. If it cannot be determined, write undefined. A lot of these programs, when the answer is undefined, are going to give you a number. So you need to evaluate. You're definitely go ahead and run these programs so you can mess around with them and learn what's going on. I'm not stopping you from that. I'm just warning you that the answer it spits out is not necessarily the answer I'm looking for. Because again, if it's value and it's known, write the number. If it's a pointer, tell me what the memory address is pointing to. aka variable x holds the memory address of variable y. If it can't be determined, undefined. Okay, more quickly, A, what's the output? Z equals, well, tell me if it, if it's a number or what Z is actually outputting. What is the value of y? In what memory, stack, static, or heap do the variables x, y, and z exist during runtime? Another program, what's the output? Again, go ahead. In what memory, stack, static, heap do the variables x and z exist during runtime? There's x and z right up there. Why is this code bad practice even though it compiles and runs without a seg fault? Hopefully we've talked about that. Yeah, we have talked about that a little. Definitely have. What is the output? Careful, compile run will not give the correct answer on this one. Oh yeah, it won't. In what memory, static, stack, or heap do the variables x and z exist during runtime? So there's x, there's z. What is stored on the heap in this example? There is something on the heap. What is the memory issue here? Hopefully it's fairly obvious. And yes, we did go through it. If you don't know, you can't figure it out, run the program and, compile the program and run it under Valgrind. It should spit out the answer for you. Here we go. X says 100 variables. Y points to there. We set all the x's. And y is the output. Y sub 10 equals 20. Well, we're going to the 10th index of this array. Write a line of code that would free up memory using only x. And then write a line of code that would free up memory using only y. Consider the following. All right, now we got x, y. We did go over this, but just as a reminder, this is a double pointer, so it's a pointer to a pointer. We're setting x and y. We're setting z here, printing something out, setting z here again, printing something out. What is the value of x and y? What is the value of z on lines 14 and 16? Hint, they are different values, obviously because they're being assigned. What does the code fragment, this guy, mean? Ooh. Describe what the code must do to evaluate the code fragment. It will probably be somewhat helpful if you go back and you look at what the solid brackets as a shorthand for, and then hopefully you'll be able to determine from there what's going on. Why are there two different outputs for this line of code? Here are the outputs of the program. Yeah, you can run them, but there are the answers. Write the commands to free memory. Okay? All right, this is a hard one. I'm warning you right now. Here's a line of code, or lines of code. We're creating a student class. Just think of it like in Java, except for when you do this up front, that means all these variables are public. And these are strings, doubles, and int. Hopefully that's fairly straightforward. We create student, which is 100 students, and the student double pointer, which is 100 student pointers. We're going to make a random number. This just randomizes the students. This sorts the students based on GPA, and then it prints it out. I'm telling you what the code accomplishes. You don't need to know how bubble sort works. You don't really need to know how the randomization works. What I'm saying is this part right here, I've told you what it does, gives it random values, and then sorts it. That's what you need to know. Then prints out, okay, their GPAs. What's the value of students? So there's students right up here. Which of the above is being stored? Which of the above is being, sorted, okay. Whew. What's being sorted? Well, the two things that can be sorted are this guy or this one up here. Those are the only two data structures you really have. Why was the above in C chosen over the other? So remember, there's two of them here. Why did I sort one of them and not the other one? Might be, that you gotta sit down and think about why that was chosen. Why would I choose that? What advantage do you see? Write the commands to free memory. Oh, okay, I took the hard question out. Great. And then write the commands to free memory. The hard question was, I want you to sort in O of n time. But we're not going to do that. So the only question that's going to be any difficult here is D. And I just want to see if you can give me a good reason for it. And this is, of course, due 1 week from today. Any questions on this one?
Lab 6 is due a week from today as well.
That's correct. Oh, so webhook. Did y'all do webhooks in OOP?
No.
All right. This isn't changed. Go to your GitHub. Go to settings of your project. Go to your project settings. Click on webhook. Put that payload in. That is correct. Select JSON. The default is not JSON. The default is something different. Make sure you select JSON. Click Add Webhook. All right, the way this works is whenever you push the autograder, if it's set up correctly, or when it's set up correctly, I got it set up this morning, I haven't had time to test it yet. The first time you push, it takes about 10 minutes for it to work because it has to pull your repository to a machine that's back there, and our internet connection right now is poor, so it takes some time. But after the initial push, talking to students, it takes about 10, I'll say on average, under 30 seconds for it to grab your code, run the test, and then give you your response. Your response is going to be pushed back into your GitHub repository. There'll be a grade.txt that outlines what your grade is. All right, this lab's review of arrays in C++. All right, they have similarities. We already talked about this. We actually wrote a bunch of test cases, in fact. And it's due 1 week from today. Please write some of the tests. We pretty much wrote them for you. The autograder is definitely using a different set of tests, so hopefully the two overlap enough to where when you submit it, you'll get your grade back. And the autograder will tell you what your grade is. Again, I talked about this at the beginning, but just to make sure we're clear, the autograder gives you what your highest possible grade can be. I can go in, and sometimes I do, I go in to inspect if there's any other reason to deduct points. In general, most of the time I don't, because there isn't a reason, but just keep in mind that what the autograder gives you is the highest grade that you could get, because some of these other labs actually require something in addition to the autograder. Again, no teamwork. Your work must be your own. Any other questions? All right, good. We finished only about 2 minutes late. That is all I have for today. And that's it for the week, so we only meet once. Have a good weekend.